And so tonight we're talking about Ethereum as a cryptocurrency. This is the second part of a two-part series. I gave a few weeks ago the first part of it. The first part was more of an introduction to Ethereum as a smart contract system. And this one is a continuation of that topic. If you need Wi-Fi access, that's available as well. Just a little bit about myself. Again, my name is Brooks Boyd. The reason why I like presenting on these things, I got into the cryptocurrency space starting with Bitcoin in around 2012. And I've done development with the core client. Back then it was creating altcoins, forking off of the main core client. And since then I've gotten into Solidity and Ethereum development, and that's more what I do as my freelance work nowadays. And so excited to share that information with you. And so the point for this talk is I'm coming at it from the aspect of a developer. I've been studying this stuff, getting down into the code. But from that perspective, I'm giving it to you as a user of how are we using the smart contracts is the focus of it today. Since a key point of the Ethereum blockchain is what makes it different than Bitcoin and some of the other cryptocurrencies is in addition to being currency, you can do stuff with it. So we're talking today about what sort of stuff that is. For contacting me, the Madison Blockchain group does have a Slack group, which has links from the Meetup About page. If you jump in there, I'm Midnight Lightning there. I'm also Midnight Lightning on GitHub and other places around the interwebs. Or you can email me directly there. All right. And so to start off with, I'm up here presenting, and obviously I've been kind of endorsed by the Madison Blockchain to present to you, and in theory what I'm saying is factual. The one thing to bear in mind when you're dealing with cryptocurrencies and learning about them in general is the concept of trust. All of the cryptocurrencies, from Bitcoin to all of its derivatives, Ethereum included, one of their features you may often hear touted is that it's trustless, that you don't have to trust anyone, or that you're trusting the math, you're not trusting a person. And that's true. And it's all based on that premise. We come from a lot of what we do in the real world, we have to somewhat trust the people that we're interacting with. And so part of this is you will be interacting with people in the cryptocurrency space where you don't know and possibly wouldn't trust based on real world experience, but you can through the math and cryptography of it. And so the question is how, looking at me as a person who's about to teach you, it's either the am I your Dumbledore or am I your Cato? And as I presented this at the last one, anyone not know Dumbledore, the character on the left there? I'll use that one. Anyone does know the character on the right? I remember, what franchise is that from? The Pink Panther franchise. As I explained in the first one, the difference here of the way the teaching style and also as you as a student should approach this, Dumbledore in his Harry Potter universe, you may look to him as the wise person, the mentor who can keep a sheltered environment. His domain was completely controlled. He had absolute authority over his castle, and he kept his students safe until they were ready for it. That's not really possible in the cryptocurrency space. There are lots of avenues that cannot be controlled. On the other side, we have the Inspector Clouseau of the Pink Panther fame, who knew that he needed to be ready for anything at any time. So he wanted to prepare for how to be ready in a surprise attack. And so what he did was hired a martial arts expert, Cato, to not only teach him karate, but also given him the instruction to attack me at any moment. Because the only way you can prepare for a surprise attack is actually to be surprise attacked. And so that's kind of the idea here, is treat all of your teachers more like Cato. And as I go through the written guide that goes kind of along with this, which this presentation is based off of, I talk about kind of like a pothole versus a cliff. I'm going to be trying to teach you. I did intentionally put potholes in some of these examples to catch you, to trip you, to teach you. They're potholes, not cliffs. They won't kill you. They're intended to teach you a lesson. Through this presentation this evening, I'll be showing you the safe way around them. But the point being, then you should go explore and also then see if you can find the potholes in a couple of the things that I've built in that you can practice for when you're out there in the real world. So what was covered in part one was taking a look at what makes Ethereum different than Bitcoin and some of the other cryptocurrencies. That layer of, you start with Ether, it has value, same as Bitcoin, you can get it, you can have value. Then you have a smart contract idea, which is a set of rules written to the blockchain that dictate how things work. We covered some of the basic transactions, and basic smart contracts. One of the basic interfaces, kind of a standard that has evolved, is the Erc20, the Ethereum request for comment number 20, which has become fairly popular, as a definition of what any sort of a currency or a token should be. And so, as we learned in the that one, I created a token, a unicorn. It's a real unicorn. Don't let the name fool you, even though I called it a cardboard unicorn. The horse with a cheap cardboard horn, Watch, is a token I created. It's similar to like a Chuck E. Cheese token. It is something that I completely created and I gave value as a developer. Or you can also view it as like a punch card that you would get in a coffee shop. You could collect these and you might be able to trade them in for something else. You might not. Most people won't accept them as currency, but we still need to count them, keep them somewhere, and move them around. So if you would like to actually participate with these, you will need some Watch. 5 would be fine, 15 would be great. 50, you're just showing off. I have a couple thousand. That's mainly because I made it. I can have those. If you want to get some, while we're getting started here, if you use the Ethereum name service and look up the unicornsareus.eth account and send 0.005 Ether to it, you'll get 5 Watch to just start off with. And we'll go over a bit more detail of that as we go through. So as I said, I created a bunch of contracts for practicing this. And so the story around this one, we covered the first two in the first presentation. The Cardboard Unicorn Assembler is the contract that has logic where if you pay it Ether, it will give you brand new, freshly minted cardboard unicorns. The where it actually records that you do have those unicorns is a second contract. So the Cardboard Unicorn contract is the one that adheres to that Erc20 standard, the ones that have a kind of a baseline of knowledge of what a token should be. And today we're going to be covering that Unicorn Ranch one as the new piece in this puzzle. And that last one is the verification that you can see. That last address is mine, which created all these. And as we get started, let me just go over again the proof for that one. These visual indicators are called blockies or identicons, which have been used on several Ethereum sites to help just verify that this string that you're at is the one that you think you're at. So as an example, to just prove that I am who I say I am, to get started, that I am actually Brooks, I didn't just steal his laptop in his presentation. Let's start here with this Unicorn Assembler, unicornsareus.eth. I'm going to use the Etherscan Block Explorer again tonight. This is a free service that's there to just give you a look into the Ethereum blockchain. There are many block explorers. I encourage you to try this on other block explorers. You don't have to use this one. But if we look up unicornsareus.eth, it's going to say that this one is registered to 2DC588AF. And if I can get my keyboard commands to work. 2DC5AAAF. Yep, that looks about right. Let's click on that one to actually go visit it. And as we get here, indeed, Etherscan also shows a little tiny blocky in the corner, which should be the same one that I was looking at. So yes, there's your double check for that one. Also, then the link, as we showed yesterday, or not yesterday, the last presentation, it was a bit longer ago than yesterday, we can know this contract is not owned by a human because it actually has a flag here saying contract creator. It was created by this account. And if I follow this one, we can see here this one does not have contract creator. So this is owned by a human account. And this one, as you can see from the blocky up here, has that green and purple horns sort of a looking one, which I'm claiming is me, the creator here, 6954DO. 6954DO. Now one way that I can prove that that's for me is because it happens to be my MetaMask account. So if I pop up here to my MetaMask browser extension, it has a link here that if I go to view my account on Etherscan, if I click that and hands off keyboard, it should arrive at that exact same page. Yep. So here's that same one, and that is that same identicon there. Hopefully some at least light proof that I am the one who actually created that. And so we're talking about those two contracts. Those are the first two pieces. But now for tonight, we're looking at the next piece of that puzzle, this Unicorn Ranch. And let's see if we're here. Before I get into that one, so let's talk about the base that we're building upon. So we've already talked about the idea that when you start out on the Ethereum blockchain, the same way that starting out with a new bank account, you create a wallet, the wallet is empty, has no value. You then acquire some Ether, the wallet then has some Ether and is worth something in Ether. Ethereum then lets you take one more step further of you trade the ether for something else. Usually if you did that with your bank account, if you used your money to buy something, that something, you bought something on Amazon, that something is now not in your bank account. It's now something that exists, maybe in your house. With Ethereum, that something still exists in your wallet. The same wallet now has that additional thing in it. And because you can keep now layering on top of it, instead of spending ether on something, you could spend that other thing and get now a third thing. And you could go as far down the rabbit hole as you need to in terms of development to get something there. So it's this platform that keeps layering it up of ether is the base layer, but it's based on the idea that you're going to swap ether for something, and the reason why you want that something else is because you can swap it for something else even further. And just a note on why Ethereum in general. Right now we've been seeing a boom of lots of different cryptocurrencies being launched, lots of new ideas, lots of new projects. Ethereum in general has actually been in the news in the last week or so. Two big ones that I just pulled out of this. I mentioned the MetaMask as a browser extension lets you put an Ethereum wallet into a browser, and MetaMask is there for Firefox and Chrome. This week, Opera announced that they're building in an Ethereum wallet into their Opera browser by default. No extension needed. It's just going to be part of Opera Mobile. So big step forward. They're the first browser to actually announce that they're going to be doing that natively. And they chose Ethereum as the wallet that they're going to be adding in. Also, Major League Baseball, a completely not, maybe not the first company you think of when you're thinking of high technology piece of thing. They announced this week that they're building on the Ethereum blockchain a video game piece for interacting with their merchandise and actually having physical, their physical bobbleheads or merchandise then have a representation on the blockchain for proof of ownership, and then having a representation in their game where you'll be able to level up, or it's looking like it'll be more like an RPG if you can level up your token and figurine sort of a thing. So lots of companies starting to get into the cryptocurrency space and picking, some of them are picking Ethereum, which is why it's got a bunch of clout, and moving forward is a good one to at least learn how to utilize. So I talked a little about your wallet and the stuff that's on Ethereum, and just a moment on where the stuff goes or how the stuff goes. Interacting with Ethereum, you create transactions that actually trigger stuff to happen. The most basic transaction is simply send ether from address A to address B. Pretty much all cryptocurrencies would do that. That's your basic send the value somewhere else. However, because Ethereum also has contracts that have logic, and those logics are termed functions that you can be called, that second form of you can also send ether from address A to address B, and assuming address B is a smart contract, tell address B to do something, call some function. And so those are the two main forms of transactions that Ethereum can have. Everything else kind of builds on that and can abstract away some complexity. The Erc20 standard, the idea that you have some other representation of a token or a currency, in reality, it's a function that says, send 0 ether from one address to another, and then execute a transfer function. They've decided the name should be called transfer, just to make it universal across all these tokens. So they know the function should be called transfer, and it should be the actual token address. So it looks like your wallets can make it look like they're doing a send this token, send watch from address A to address B. It looks a lot like this original form of the ether transaction, but it's actually doing something in the background that's utilizing that second form. And so all the things that we're building on top of it take that second form of transaction and make it a little bit more user-friendly for the most part. But what we're going is kind of peeking under the hood and looking at what's really going on there and seeing that, making sure that we can actually trigger it the way we want to if we need to. And one final note on transactions, the concept of when stuff goes. We're used to computer programs being able to do things automatically, and often we have computer programs that will do things in a batch process. Your email client checks email automatically every 10 minutes or whatnot. On Ethereum, every action has to be started by a human. There is a transaction that gets initiated and sent by a human to trigger something in the blockchain. A contract that gets triggered can also trigger another contract, and so you can get this line of dominoes that a bunch of things trigger, but at the very beginning it has to be a human who actually triggers it. And that means, so now that we're at the idea of we have watch, and what are we going to do with it? You might be able to find a buddy, maybe they came to this presentation, and they're willing that if you send them watch, they will give you a cupcake, that you can buy a cupcake from them with watch. That's a real world transaction. You can have the watch be on the blockchain, but then it's up to the human to actually fulfill their end of the bargain. Do they actually give you the cupcake they said they would? The benefit of having the smart contract logic do it is then it's completely contained within the logic of the blockchain and forced to be what it says it is. But the same concept applies that if you're loaning something to someone, you're giving your watch to your buddy for a little bit and intending them to give it back. If there's any sort of time delay where the ownership has passed that you actually give the watch to someone else, it's then up to them to transfer it back to you. If they refuse to, you're up to then your human means of convincing the person to transfer it back to you. So what we're going to try doing today, that Unicorn Ranch contract, is something where you can send your watch to it. It's a retreat, it's a spa. Give your unicorns a break. So we're going to send some watch to the ranch. The ranch is a smart contract, there's no human behind it. And so it's the idea of how do you make sure that you get your asset there and get your asset back again. So this Unicorn Ranch contract, the unicornranch.eth, let's take a look at that one here. All right, and we'll take a look here. Etherscan says 97E7EF. You can even peek here before we even go there. 97E7EF, that looks like it's going to be about right. Let's double check. Going here, and is even, yep, does that blocky look familiar? Yep, that should be the same one there. So we are at the right location. The same sort of checks we did the first time we should do here. Is this owned by a human or is this a contract? Audience participation.
Human.
Not human.
Contract.
It has a contract creator, therefore it is not owned by a human. It was created by another account. So this one does have smart contract code. The other trick that you can see is smart contracts will have a code tab down here on Etherscan. That's specific to Etherscan as well. Let's double check here the creator going here, and we'll pull this one up. Does that look familiar? There we go. We're back to this one's my address again. And again, this one does not have a contract creator here. It would actually be right here above the token balances, as we saw for this one. So this is a new contract that we're interacting with. As we saw in the last presentation, code is a chunk where Etherscan will actually show you what's on the blockchain. The raw amount of data the raw information on the blockchain is this code. I, as the developer, have input this code and told Etherscan, hey, by the way, I created this, here's what I used to create that output. Because when you're developing for Ethereum, it's easy to go from this to this, but it is extremely hard to go the other way. So I helped Etherscan by saying, here, this is the pretty version of the code, and can you verify that for me? Question?
Sorry, quick logistical question. I missed the Wi-Fi password, but I want to follow
Sure.
along.
Easy enough. It's right behind you on the wall as well.
Sweet. Thank you.
You're welcome. So for this one, so to verify the green check mark that's here on Etherscan, this is Etherscan putting its stamp of approval on it, saying, okay, we received this information. We're not vouching for what it's going to do, but we can at least vouch for saying, if you put this code in, this is what's going to end up on the blockchain. The developer is being honest about, here is their code. So we can at least start from that point. This contract is much more complex than the one we dealt with in the previous presentation, so I've actually sliced it out here a little bit. Let's just take a look at these. Oh, firstly to notice, we're now dealing with these three contracts. The first was the Unicorn Assembler, where you could purchase a unicorn. The Watch contract is where it records how many Watch you have. And now we've got this Unicorn Ranch contract. Looking at the next tab here is what I wanted to pull up. Read contract is where Etherscan lets you see any of the free functions that the contract has. Etherscan will just go ahead and show it to you for free because it knows that it doesn't cost anything to do these. And you can see in here, this has a link, cardboard unicorn token address is a parameter that is encoded into this smart contract, which points over to this guy, purple monster, green face guy, which we've seen before. And we looked at last week, the purchasing contract has a link to that contract. So both of these two contracts have a point to that central ERC20 one, but note that the ranch does not have any link to the assembler. And the reason why I gave these kind of two separate names is also to illustrate the idea of, for these examples, I created all of them. But in the real world, this unicorn ranch contract could have been created by someone completely different. Someone who decided, hey, I want to give value to Hwatches. I'm going to use Hwatch as my base currency. I'm going to make an application that accepts Hwatch. They can do so. They just simply need to point to where is the stored of who has how much. So they're completely separate. The unicorn ranch does not need to know about the assembler, nor the other way around. They only need to care about that central interface of who has how many of these tokens, piece of it. So we've verified the contract. I've told you as a developer, hey, this is a spa for your unicorns. Send your unicorns here. Well, how do you send unicorns here? We talked about in the last presentation, the Erc20 Standard says that if you want to, the function that moves the tokens from one address to another should be called transfer. And it takes the address of where it's going to go, and it takes it from your supply when you initiate that transfer. So it's the where do you want it to go and how much is it going to be. So set the destination to the ranch and transfer your Hwatch there. As an example, let's do that. So I'm going to need the address of the ranch, which I've still got pulled up here. So I'm going to use my Ether wallet as an interface to get at my MetaMask account here. And I want to send my Ether wallet has a nice interface for sending tokens directly, where they abstract away some of the complexity. But for completeness, I'm going to interact with it as if there was no additional information about it. So I'm going to interact under this Contracts tab, allows you in my Ether wallet to give it some raw information about the contract, and it'll make a nice web form for you. So I'm going to give it needs the contract address. I'll copy that from here. And it needs the ABI, that stands for the Application Binary Interface. It's over here under the code. My Ether wallet, or Etherscan creates it nicely here. This is basically just a listing of all the things that are possible to do with this contract in a programmatic way. So when I click Access here, then my Ether wallet can create this down here. So we're interacting with that same contract, and here's all the stuff you can do. This includes some of those free ones, which we saw that already on the Etherscan knew that this particular function, where is the ERC20 token, is free. For that one, and I realize I did this one backwards. I'm looking at the ranch. I want to transfer to the ranch. I'm not actually telling the ranch to do anything. I have to tell the token to do something. I'm interacting with the wrong contract. I need to go to the actual place where these tokens are stored, which is this, the ERC20 contract, the one that is the Hwatch contract. So one more time, I'll copy this one. Wrong one. Let's do that. That guy. And I need the code, and I need the ABI from here. Thank you. Delete that one, put in that one. Different set of functions. This one has some, like, the name is a free one. There we go, the horse with the cheap cardboard horn. I'm on the right contract. This is one of those free ones. So I want to send to the ranch. I want to transfer to the ranch. I have a transfer function. So it asks me, where do I want to go to? I'm going to copy it from here this time. I'm going to go to the ranch. And I've got plenty, so I'm going to send 30 of them over there. I'm going to give them a nice little retreat, and they can go as a whole herd. My password is right, or my private key right now is in MetaMask, so it will connect. And so this is the place where my Ether wallet is a tool, but it doesn't keep your secret. It now has constructed the transaction that needs to go to Ethereum. And here when I click write, it's warning, oh, it's going to be creating something new. One thing I forgot to do here is looking at the very top here is the gas price for how much speed do you want to dedicate to it, how much bidding do you want to do for speed versus timeliness. on the Ethereum blockchain. You're bidding against everyone else who wants to get their transaction done now. I just want to double check here. It's the state of gas. And right now they're saying the safe low value is 3. I'm fine with that. I don't need it to be super fast, so I will pump that down to 3 for right now. And then right. So now this dialog with the blue border around it is still my Ether wallet saying, you're doing something very advanced. Are you sure? Double check all your numbers that you put in here. And it is right now going to say, yes, this is the amount of basically CPU power I need and all the things there. So make that transaction. Now what's popped here now is my MetaMask wallet saying, hey, this website wants you to do something. Do you agree? I have the secret to allow you to do it. Do you agree? And indeed, here it is. That same data payload, the 3 gigaway cost for gas. I say, yes, I do want to do that. Huzzah! That moved over there. That's now into the Ethereum blockchain, or basically waiting to get into there. Etherscan goes through a couple of different permutations here. You can see this is on, it's on our secondary node. They're still analyzing it to figure out what you were trying to do. They were technically out of the loop of that whole thing, so they're still parsing that. Let's see, that should only take a moment. Because this is an ERC20 token, Etherscan was able to say, wait, I know the shape of that. That's a transfer function. You're trying to execute something called transfer. I bet you're moving ERC20 tokens around. I'll make that look a little bit friendlier for you. And indeed, I'm sending to that address this amount in hexadecimal to going through. We'll let that go through. So that's how you've done transfers before. And so in the last presentation, we transferred to a human. You can send it to your friends. I've now sent it to the ranch. So what has happened to it? The ranch now has my 30, oh, and there it is actually confirmed. The ranch now has my 30 watch. We can verify that by taking a look now at, back to this one, take a look here at the balance of, we didn't actually check my own address before we started this, but I had something like 6,000 or 7,900 of them. And I believe if I copy my own address, I want to know how many watch do I have? This should now be updated. 7,000. I had 7,960. It's now down to 7,931. 631. Point being, your balance should now have been reduced. You actually did lose your watch. The ranch gained them. So what? Would be the next question out of that one. The action of triggering the transfer function on the ERC20 token, as you even saw me mess up at the very beginning, it's not talking to the Unicorn Ranch contract. It's talking to a completely separate contract. And as we've looked at the transfer function in the last presentation, or in the general standard of an ERC20 transfer function, it does not call out to any other function, any other transaction, or any other smart contracts. So the point being, what I just did, don't do. Because the ranch has no idea what you just did. The ranch was completely out of the loop. A smart contract cannot look up transactions on the blockchain. The way that we can look up the Block Explorer and see Etherscan, we as humans can see things on Etherscan as a transaction in a block. But from a smart contract's code perspective, they don't see things as transactions. They can't see that. So how do you tell the ranch, hey, I did it? They can't look up the transactions. They can't look up events. That's another sort of logging thing that a contract can do. But they can read the state of another contract. So you could do something like, okay, at the very beginning, tell the ranch, hey, look at how many you have. You have 1,000 now, right now? Okay, remember that. Then you go do something and then come back and say, hey, look at how many you have now. You have 1,030. Those 30 were mine. Well, yes, technically something happened in the middle of there, but how can you prove it was you who moved those 30 and not someone else? And also, that's 3 transactions. You telling the ranch something, going to do something, and then telling the ranch to check again. So we need a better way to actually get the ranch to know verifiably it was you who did it. The way that's been kind of decided and has become part of the ERC20 contract interface standard is this idea of an allowance. We're actually going to let the ranch be the one who actually moves the tokens. So the idea is, I own the asset, but I'm going to give the ranch an allowance to use part of my herd, part of my asset, and move the funds from my account to wherever it wants. So there's the example here is if you have 25 Hwatch to start with, you execute a function on the Hwatch contract saying you're going to give the ranch an allowance of 10. So that's one transaction. Then you go to the ranch and say, I want to do something with Hwatch. I want to send 3 Hwatch to you. The ranch then needs to reach out and use that allowance to take 3. After the ranch has done that, so 2 transactions, nicely we've dropped it from 3 to 2. Then you have 22, you've lost 3. The ranch now has 3, it took your 3, and it has an allowance of 7. Its own allowance got reduced by 3. So in that way you can set an allowance for more than what you're going to use in one transaction, so that you can set like one big allowance and then use many little transactions to cover it. That even reduces the transaction count further. You don't need 2 transactions for every move. You could just set one allowance if you know that you're going to be doing things at the ranch multiple times. So what we actually need to do is give the ranch an allowance. And that's done through the approve function. So let's do this one. That would be through, we've already got that pulled up here. This is still that Erc20 contract, the purple monster looking contract. There should be the approve function. And actually, I've done this one already, so let me double check. The approve is to grant a new allowance. To actually look up the allowance, I want to see that one. I want to see from my account, I'm the purple horns one, I want to know how much of an allowance I have given to the ranch. So I'm going to look up that much and read 2. It's allowed to still take 2 more of my Hwatch. So I can actually do, so I won't do any more for that one, but if it were at 0, I can add and approve a further allowance for it. So that one transaction has already gone through to give them an allowance, but let's see what they're actually going to do with it. So the next step in that process is I need to trigger something on the ranch to say, take my unicorns. Now I've only given them an allowance of 2, but if I say, only take 1, how do I know that they are actually only going to take 1 when I've actually given them the authority to take up to 2? We actually need to look at the code and see what it's going to do. And this is important because this process is actually moving ownership. You are losing control of your Hwatch. So here's where we're going to take a look at the code. The piece of this one, as I explained in the first one, looking at the code of a smart contract, even though you're not developers, and this is a user-focused one, I am saying you need to look at the code of it. And the parallel to this is, because these are contracts, we have contracts in the real world. And in the real world, they're usually full of legalese. And they may be convoluted, they may be complex, but we all know it's very important to understand what is in a contract before you sign it. And if you, looking through the contract, can't understand it yourself, you go to a lawyer, you get someone who knows, you get help before you sign it. Same idea here now with, we're moving to a different type of contract. The language is different, and therefore if you need help, the name of the professional who you go to get help from is different. Instead of going to a lawyer, you'd probably want to go to a programmer and get some help looking at it. But the nice thing is most of these are fairly plain English, and I'm going to help walk through a bit of this as the idea here. And hopefully it's simple enough that you can get enough of a sense of it to get some trust in it to at least move forward with it. And so I peeled out some of the code from the ranch contract. The ranch has this idea of you have several different booking types. You can either drop off your unicorn for a quick spa visit, they can stay for an afternoon, a full day, overnight, week, or extended stay. And you can see there are functions. The language that's used here starts with the word function, triggers that this is going to be an action that's going to happen, and then it gets a name and what sort of an input it needs to happen. So we have these names here, booking a spa visit, booking an afternoon visit, booking a day visit, all these ones for all the different types. But you'll note that each of them, all it does is call this additional function called add a booking. And it's just separating out by type. This is going to be a spa one, this is an afternoon one. This is a convenience function to make it a little bit easier for you to book. But the meat of it is going to be this add booking function. So let's take a look at what that does. This is the meat of the add booking function. The idea here, this first piece here, let's see if I can get, we'll get it back. That's it. That first line, require the message is the transaction that comes in, the value that you sent, the ether that comes in from the message, must be greater than or equal to whatever the cost is for this particular type. So say it was a spa visit. Each spa visit has a particular cost. It's looking up the cost, and it's multiplying it by the number of unicorns. So did you spend enough ether? Are you sending enough ether to cover all the unicorns that you're dropping off? And indeed the comment there is, are you paying the proper amount? One pothole to notice here, I'll give you this one for free. That's a greater than or equal to, not an equal to. It will not stop you if you overpay. If you send it 500 ether, that's more than you need to pay, and it will say, sure, you can keep going. I'm not going to stop you. I only require it to be over the minimum. So it's up to you to figure out the math of how much you're supposed to send with each booking. Or you can just overpay. That's a good tip. I don't mind. Then the logic continues on. It's going to look up that cardboard unicorn ERC20 token, and it's going to call this transfer from function. It's going to move it from this transaction, which you sent, the sender, so that's you, your address, to the address of this thing, so the ranch. It's going to move it, transfer from you, the sender, to the ranch, however many you sent in. Okay, that's actually accurate. That's what we wanted it to do. The point is we're going to want to get these back out again. So hopefully it needs to record that it was indeed ours. We saw the problem of if we just send it there, it needs to record it. And indeed here, it's then recording, hey, I've got more visiting unicorns added in this amount. And then here, it's going to expire at some point in the future. How long is this type of visit? What's the visit length of a spa visit is shorter than an afternoon visit. Okay, still doing math on that. Aha, here's the key piece. The contract is keeping its own internal ledger, and it's calling it bookings. It's an array from a programming perspective where each person, each sender, each human account has a ledger inside of this bookings array. And it's going to add onto the end of it, pushing onto the end of it, a new visit. How many unicorns? Of what type of visit? What is the block number right now? When are you starting? When is it going to expire? How long is that spa visit? And marking it as in progress. Okay, so good. This is actually recording that I did it. It's recording me, and I know definitely this message sender is going to be me. So there's my confidence that at least somewhere in the code, it's keeping track of that these, however many I sent, unicorn count, are mine. And then it sends some new notifications to, if other contracts want to be informed about it, it does that. So that's all well and good to drop them off. The question is, how do you get them back? So after your event is done, how do I complete it? There is a separate function called the complete a booking. But note that you only put in an index value. Let's see what it's actually doing for this one. It requires that in that bookings array, that was what we just looked at here, of it's keeping track for each person. So for this sender, it's a length of the ledger. How many items are in it? We're looking up a particular index, a record in that one. So it first checks, if you're looking for the first one, do you have at least one in that ledger? Checks for that. If so, it's going to pull that one out and take a look. Is the block right now, how far we are on the blockchain, at least as far as when it should expire? Have you waited the appropriate amount of time? If so, continue. And also, is it still in progress? No cheating, no trying to claim a contract twice, no picking up your unicorns twice. That would be someone else's. So it requires that, yes, this one be in progress. If so, then we actually want to see, does it actually give the unicorns back? So here, we're going to keep track of the unicorns that it's going to return is indeed the amount that you dropped off. That was what was stored the first time. And now it's going to go look at that ERC20 token. Good, we're on the right track. And then to determine if any births occurred. It's a ranch, there's lots of horses, that stuff happens. So there's some logic built in here. There's a possibility of you going home with more than what you dropped off. We can see from skimming through here, if you drop off at least 100 or at least 10, so there's a better bonus if you drop off a whole herd of 100 or at least 10, there's a possibility of getting some additional births and going home with more than you left, or more than you dropped off. So it does the logic, and if there indeed were births, then it adds to the unicorns to return with the births. So might get some more out of this. Interesting to know. All right, but still, it hasn't returned any yet. So here we get to the last bit here. It marks that visit as completed. So we're done, we can't claim it again. Marks when it was completed, just for posterity's sake. And it's going to mark how many to return. So it actually notes the difference between how many you dropped off and how many it's giving you back. And saves that back to the state. And here's the critical piece. It then uses that cardboard unicorns, the ERC20 contract, and it calls transfer. We know that one. That's the one we've seen before. And it transfers to you, the message sender, and now it's using it because this is not the transfer from. This is the one where it's using its own reserves. The ranch is actually sending from its own reserves back to you how many to return. So there, that line 221 is the critical one. And we've actually found, yes, it will return them if it's reached up to that point in the transaction logic. I know that was a lot to cover. If you can at least get a sense of that one, or you could trust me that I'm being Dumbledore right now and not Cato, we can go forward with this one, that the contract is actually doing that. The one nice thing about Ethereum smart contracts is the logic of a contract cannot change. There are some variables that can change, like for these, it can be like the price of a booking or the length of a booking. But actually the order of flow of what we've been looking at here, that's now etched into the blockchain and will not change. I, as the developer, cannot change it. So if you get a developer, go to someone else, go to Eric, he might trust me, can actually verify it. Once you've verified it once, you don't have to again. You know it's not going to change. Ethereum is going to keep that logic the same. Question?
What if the first time the programmer makes a mistake?
Then it's a problem. That's in the real world, we would call that like a loophole in the contract. If the question was if the developer made a mistake at the beginning. It is a new sort of development paradigm that developers have to get used to, that yes, all the logic of the contract needs to be there from the beginning. It's not like a normal software project where you can create something simple and then keep adding on to it. Instead of adding on to one contract, you instead have to do like what I've done of creating multiple contracts that talk to each other. And I've built in the means to say, like if I find a problem with the Unicorn Ranch, I can create a new Unicorn Ranch that fixes the problem and basically say, stop using that one, start using this one over here. But I have to convince people to start using my new logic. The old logic will forever be on the blockchain if you wanted to continue to use it.
So when you hear about crypto exchanges getting hacked, is this where it might occur?
There was the example, or the question was if hearing about exchanges being hacked, if this is part of that. And it may be and it may not. Most of the exchanges where you're actually purchasing cryptocurrencies with other currencies, either normal US dollars or other currencies, usually are running their own software and are not actually contracts on the blockchain. There are a few that are. Those are decentralized exchanges. But most of the ones still around are custom software in a traditional web environment. And a hack of those is usually, in a traditional sense, whoever is running that exchange service, their computers got hacked, passwords got stolen, those sorts of things. So no, not quite, for most cases. Yes, in the back?
That's kind of a follow-up question to the previous one. So you explained that if you wanted to change the ranch, you would make a new contract and have to convince people to switch. What if you wanted to change the unicorn assembler? If you tweak that, is that a whole different, like that's a knockoff cardboard unicorn then?
Yes. Yep, and so yeah, the linkages between them, I had to develop in the functions that allow me as the owner of it to be able to change where it's pointing to. And yes, it's only as flexible as I built in that first time. And I did build in the ability for the assembler to point to a different cardboard unicorn contract if I needed to.
Okay.
Mm-hmm. Yep, over here.
Isn't it possible that the ranch keeps your unicorns if you have newly birthed unicorns, but the ranch actually doesn't have any to give? So then when it runs that, then...
Yes, good catch. There is a pothole there of there are some surplus ones, and I've pre-filled the ranch with a couple of extra unicorns. If the amount that you're supposed to get is too much, note that it actually checks against its own balance of how many unicorns do I have, and if you're supposed to get more than it has, it just truncates to I'm going to give you all I have. So you might get cheated out of you were entitled to more unicorns, but I just don't have them to give. But you asked me to give them to you anyway, so I'm going to give them to you. Piece of it. And that's the way that one's built in. I could have had it throw an exception and just stop you and force that, wait until the time when I can actually give you all the ones. But right now, it actually has the logic of, they wanted it right now, so I'll give it to them right now. It might be slightly less than what they were supposed to get. Piece of it. All right, and this just covers what I was just going over of the logic cannot change. Once you've verified that function once, and you know that contract, by verifying the block keys or the actual address ID, you can know that it hasn't changed because the blockchain will keep it that way. So actually, let's do that. Well, I'm actually going to send, let's see, so I have an allowance of 2. I'll actually just send the 1 for right now. But right now what I've got pulled up in my Ether wallet is interacting with the Erc20 token. We set up the allowance. Now I actually want to tell the ranch, go ahead and add a booking for me for my 2 watch. So I need to go back to what I did the first time of grab, is this the ranch? Nope, that's the one. Is this the ranch? Nope, that was my transaction. Right, that one. Unicorn Ranch. Pull that guy back up. All right, that looks familiar. I'm gonna pull that one back up. And you know, this is a little bit tedious because it's working with a very low level aspect of the code. My Ether wallet gives you this access to the very low level piece of it so that you can have confidence in what you're actually doing if you want to interact with it. It has other tools for more simplifying it. I'm going through the very nitty gritty of it to show you this is with no varnish on it. This is actually what it's doing. So this is now the Unicorn Ranch contracts options. Let's check and see how many are currently visiting. There's 38 in there. I don't know how many are for actually people who have bookings out there or might be waiting as births to happen. But let's go ahead and I want to book a spa visit. One thing to note, the length of all of these. The lengths were indicated in the code as a variable. And we can actually see here, where is the visit cost. The visit cost needs to take an index in the array. The 0 is your the spa visit. And the cost is 0. Oh good, spa visits are free. I don't need to spend any money. Put that as a discount. That's a one-time discount for all of you. If you want to send them as a spa visit, don't need to do that way. So okay, don't need any ether. The others, I need to know how long is this going to be, a visit length. The spa visit is the first in the list, so we'll check here. A spa visit is 720 somethings long. Those somethings are blocks. And since we know an Ethereum block comes about every 10 seconds, so 720 times 10 seconds, it's about 2 hours is how long a spa visit is. So if I send my unicorns here, I don't have to send any ether. They're going to be locked up for 2 hours, and after that I can get them back. Sounds good. I don't want to deal with them for right now. I've got enough unicorns. I'm going to send them off to the spa, these last 2. So I want to book a spa visit. I'm going to book 2 and write. My Ether wallet will generate that one. The gas limit should still be the same there. I'll make that transaction. And so note here again, I'm sending 0 ether as the actual payment here. However, I am sending data along with it, which that data is the call to execute the book a spa visit piece of it. I'll submit that one. Nope, I was even too fast. It hasn't even gotten over to Etherscan. There it is. And here it even noticed, oh, this is going to be a book a spa visit for 2 unicorns. So that's on its way. Let's take a look here. All right. So as we just saw, a spa visit takes 2 hours. And as I mentioned earlier, when those 2 hours are up, Ethereum won't do anything to give my unicorns back immediately. It's up to me to call the complete a booking method to get my unicorns back. And I can do that a minimum of 2 hours from now. But I could do that 2 weeks from now. It just has to be greater than 2 hours from now. I built in, because me as the ranch owner, all these unicorns sitting around are just going to be eating up food, and I don't want to be, if you only paid for a spa visit and you leave it here for a month, I'm the one who needs to pay it or feed it and clean up after it. So I did build in a repossession function. There is a function on the Unicorn Ranch to repossess a booking. The complete a booking has to be called by the person who created it. Only you can complete your own bookings. However, anyone can repossess them. You can repossess someone else's function, or repossess someone else's booking. There is, however, a timeout of repossession blocks. And right now that's set to 5 days. So if you check them in for 2 hours and you leave them sit there for a week, it's open for anyone to say, look, this booking, I found it on the blockchain, it's at this address, this index, they've been there too long. There's logic where the contract will say, thank you, I will indeed cancel that one. I will claim all of their unicorns, and as a thank you for you being the one who repossessed them, here's a bonus set of watch for you. You get part of the herd that we just confiscated from someone. I put that in there as now me as the owner of that contract, I don't have to be constantly monitoring the blockchain to find bookings that are going too long. Actually creating an incentive for if you don't even have any watch and all you want to do is sit there and poach others, you can do that. You can actually sit there and be the repo man. I actually made a financial incentive for you to do so. You can get more watch that way. Also, make an incentive for you to make sure that you're doing your things on time. Though, now if you take all those fun things that I just said and you take all the naming pieces away, this watch setup is really an example of, as a financial vehicle, you could call it like a certificate of deposit. You take an asset, you agree to lock it up for a certain amount of time. When it's time to get it back, you get at least that back, and you might get some interest on it as well. Here there are births, so you might get more unicorns. That has a lot in common with either a savings account with a low interest rate or a certificate of deposit idea. Also, what has become fairly common in applications on the blockchain is the idea of staking. That if you want to lock up some of your funds to prove that you have them and that you're not going to use them, they then give you some additional benefit for having them locked up. And this is an example of that. You lose ownership of them, probably for some length of time, and then something happens when you get them back. Maybe membership, maybe voting rights, or something else. So this is kind of an example to practice that idea of staking, and also can you get yourself a profit? Not all bookings are going to turn a profit. Those birth functions only work under certain scenarios. You have to actually adhere to them in order to get a profit out of it. So from these pieces, so this layering on top of the contract here, let me verify that this one went through. All right, this did go through. So my book spa visit was successful. 3 minutes ago, I talked for a bunch, all right. So looking at here, the one thing that we need to know is, okay, it was added, and it was supposedly added to this register. Looking up the bookings is a free function. I could do it over here on my Ether wallet. There is the get booking, where I could get the information about it. But actually, because it's a free function, I can also do it here. Because Etherscan knows that it's a free function under read contract. The exact same one here, get booking, is in that same place. So let me do, what I actually want to know is for my account, I want to know how many bookings I've currently got. Query. I have 7. I've checked into my own ranch a few times. So I want to know, for that one, I want to get my 6th one, which I believe, because it's a 0-based array, it's going to be off by that. So here it shows, indeed, the last booking in my list was for 2 unicorns. It started at this block and will expire in this block. It's currently in the state of 0, which relates to that in progress one. And indeed, so it is actually recorded there on the blockchain. That actually did execute properly. Let's actually look back in time at some of the other ones that I did. There we go. Oh, and that one, oh, I should do something about that one. I have a booking out there that's still in a state of incomplete, but has been left out there for a while. Someone could go repossess that one if they want to. That one also, I have to go back in time a little further here. There you go, state 1. This one was completed. I sent 42 unicorns for a more extended one. This one was for not a spa, not an afternoon, but a whole day visit. And this one is now completed. I sent 42 at this date. It expired then. And this was the completed one, and I actually got 46 back out. There were, what would that be, 4 births that happened during that length of time that was in there. So you can actually see these pieces that are in here. This is obviously a very low-level, granular view of it. We could make a website that makes a much more pretty interface on top of this, but you can see this is the raw data that's there in the blockchain, and that is publicly available and cannot be modified now that it's in there with that logic. Back to this one here. All right. So talking about sending assets to a contract. We talked today about how contracts can talk to other contracts. Things can trigger other things. We looked at the Unicorn Ranch does that in that the ranch triggers the transfer from function on that ERC21 and the transfer one to actually say, hey, if you want to complete the booking, that means I'm going to give you the watch back. I need to actually call a separate transaction or a separate method on a different contract completely to actually accomplish it. Contracts can talk to other contracts. but they have to be started by a human. We talked about the allowance infrastructure. That's kind of your stopgap to show you're giving permission to another contract to do something with your asset, the assets that belong to you, but then you have to verify what the logic is that it's going to do with that. And also looking at the more advanced data structures like we just did on a contract that you can get at that low-level information. If you're going to be utilizing an application or such that claims to be Ethereum-backed, odds are they're going to have a nice, pretty website that shows you that information. But if you want to verify that their website is actually doing what it says it does, doing of looking up the data on the blockchain, you can use a tool like we just showed here with Etherscan to actually look at that data as well. Let me pause there before I go further on that one. Any questions up until this point on that structure at this point? Yes?
So in my Ether wallet, you're doing some other functions that were like quote unquote free.
Yes.
How are they free? Like what's doing that computation or for you like to calculate something?
Sure. The question was the difference between how it knows the free versus the paid ones. Which ones need to have MetaMask sort of pop up and give permission to it? The answer to that one is that as part of the code, it can tell if it's going to change data on the blockchain. Anything that changes data needs to be signed and costs gas to do so. Anything that all it is doing is reading data, and even in this case of like looking up how many are in an array, or even doing some simple math of what is the expiration date for this one, can be done for free because it's a read-only function. It's only reading the data out. It's not actually affecting the state of the blockchain for those. Yeah. Or any other questions in the back? Yeah.
So I'm just always thinking about, okay, so which party ultimately pays to do the computation? Is that Etherscan then that is politely providing that for you?
For these free ones, yes, there was some CPU that was used to go read the data. Etherscan is running their own Ethereum nodes, the actual software that's doing the peer-to-peer communication with all other Ethereum nodes on the planet. And yes, they're nicely donating, saying, well, if it's not going to cost us anything, we'll also provide a little bit of our CPU resources to go look it up for you on that, yes. And there are other places that serve that same sort of a purpose, providing a free access to the free functions on smart contracts.
Is there a way to test the program before you put it on the blockchain?
Sure. The question was, testing a program before you put on the blockchain. From a developer perspective, yes. Ethereum has several what they call test networks that you can either publish it. The test networks are global, but just kind of everyone agrees that it is a clone of Ethereum, so everything works the same, and you can get quote-unquote Ether on the testnet. It's just everyone agrees that the Ether on the testnet is worth nothing. So it's free to give and free to destroy. There's also development packages where you can make kind of a mini Ethereum network just on your computer, so that then you can actually try deploying it and try interacting with it as if it were on the blockchain, but really it's only on a virtual machine inside your one workstation, which is usually the development process that developers go through. All right, now continue out with one thing. Oh, yeah, one more question over there.
So these smart tokens, the ERC20, we're assuming they're all unicorns, but what if every unicorn had some unique feature? Is there a way to code in a function so that you can have each asset actually have a unique ID, or not just an ID, but some extra data?
Yes. So the question was for the ERC20 tokens, are they all the same, or can some of them be doing something different? And the answer is yes. The ERC20 interface or standard is meant to be a baseline. It's you must have at least this. And also, it's the only part of the definition of the ERC20 interface is only the name of the function and the intended purpose. So like the transfer function, which is the common one, move it somewhere else. Most tokens will let you transfer at any time if you happen to have the worth of it. Although some contracts will build in the idea that maybe the maintainer could freeze transactions if there's a breach or whatever. Or you could make a token that says you can only transfer it on Sundays. The function is still the same, transfer, just it will always fail unless today happens to be Sunday. So the logic of those functions is completely up to the developers. The name has to be the same. And then you could have things in addition to those functions to do more logic with the ERC20 tokens if you wanted to. You also talked a little, we're starting to go towards the what about uniqueness, or like if each token could have its own ID. And that has kind of evolved. That's the formal term for that one people will give is the non-fungible tokens. It's the idea that it's not like a Chuck E. Cheese token where every token is just as valuable as any other token, but it's the idea that it might be like an IOU. An IOU from me, you can definitely trust. An IOU from Eric, well, no. Is it? That it's those sort of things. Of any one IOU, you have to base it on how much you trust the person. You may not value it as highly, sort of an idea. The non-fungible tokens, yes, you may still have a wallet that says you have 10 of them, but it then also keeps track of you have these exact 10 and they have these identifiers. The one very popular example of that one is the CryptoKitties application. Whoops, not that one. There we go. The CryptoKitties application is that idea of their tokens are cats, and you can have many of them. And let's go over here because, yes, I have some cats as well. And so right now, what this website is doing is behind the scenes calling that balance of and checking to see what do I have. I have 4. Actually, I think I have 5. 6. Hey, I had some more. I've got 6. I've got these exact 6. I have the 6 that have these exact unique numbers on them. So yeah, each one has a number, and of course the way that they've coded it is each one has a fur color, a pattern, an eye color, and so this particular one is a leopard patterned with an Egyptian coal colored fur sort of one, and so you may value that more highly than if it didn't have topaz eye color for it, sort of a thing. So a very fun implementation of it, but this has kind of spurred people to start to think about this idea that not only are there different attributes of it, they've also built in this idea that the reason why it has a gem here is that there are some mutations that appear. That Egyptian coal that color was a mutation that was introduced at some point, and this cat is a direct descendant from one of the first, I think it was 500, who first had that. The ones that don't have a gem, they're later on, past the first 500, sort of an idea. So there's all these sorts of attributes about one token that might make it more or less valuable should you wish to trade it. But yeah, that's the idea of a non-fungible token, which has become, or is becoming a standard. That's the ERC, 721 is what's becoming the standard for dealing with non-fungible tokens. ERC20 is the idea of a fungible token.
Have you actually traded?
Hmm?
Have you ever actually traded?
Do you want this one? I'll sell it to you right here.
I've wondered.
I have not traded these ones. I've just been starting to experiment with them. So, nope, I haven't become a full-fledged CryptoKitty breeder at this point. I'll stick with my watch. Well, I'm getting onto this one of, so that taking what you've learned from these sort of example watch ones, one piece, and we may have some developers here, I know we had some of the RSVPs who were interested in some of the writing your own piece of the contract. There is this one, this website is a very good tutorial piece. Crypto Zombies takes you through, it's put up by the Loom network, or the developers behind Loom. They do a very good job of walking through learning the code to actually write your own contracts. I would also recommend this for anyone, just on the simple fact of I'm encouraging you to say you should know at least how to read the code. And they walk you through some very simple exercises. And the nice thing about it is going through these exercises, you actually write the code. And as far as a memory trigger, if you actually do it, you have more of a chance of remembering it. And so this takes you through step by step. There's 6 different lessons to go through of going from nothing to a working game where you make an ERC20 token, ERC 721. You're making a zombie, which has different attributes, and you're interacting with it that way. So it's a very good tutorial tool, both for learning to write contracts and just learning how to interact with them and being able to know what contracts are doing from a lower level.
So, another question, is that basically like learning Solidity? Or is
Yes,
that,
exactly. This is a Solidity, actually I'll pull it up here. It is Solidity, and that's the language that I was showing earlier for that one. I'll not sign in just to start here. So it walks you through the idea of we're going to start with a contract. It gives you instructions on one side and gives you a Solidity editor on the right and steps you through and checks to actually make sure did you actually do it? Nope, you've got some errors going through and write your code piece of it. So a very nice walkthrough tutorial for getting started with Solidity, which is the language that most contracts are written in.
So how does Crypto Zombies make money?
Crypto Zombies is kind of a side project from the Loom network people. Loom is working on a couple of other big platform ideas, and so partially it's just getting their own name out there, and also training in more developers because they're building a platform that they want to attract more developers. So it's in their best interest to have more people who know how. But yeah. All right. And so what I would give you as homework to do after this presentation is I would highly encourage you, we're obviously recording and we'll publish those videos, and also I've shown the links to this whole guide as a written guide. I would encourage you to do the whole thing again. I stayed very strictly to Etherscan and My Ether Wallet as tools piece of it, but as I mentioned, they're not the only ones. Etherscan is a block explorer and My Ether Wallet is a wallet or tool, a transaction tool. I would encourage you to go find a different one of those and try doing the whole process again, just to familiarize yourself with the tools and also prove to yourself there's nothing magical about Etherscan or My Ether Wallet. What you're actually interacting with is one step lower of the data on the Ethereum blockchain that's being worked with. Which actually, when I originally created the written guides, there were not many things like My Ether Wallet. Since then, actually, the development team of My Ether Wallet split, and there's now My Crypto, as well as My Ether Wallet. So there's actually two websites that are very similar and do a lot of the same functionality. Try doing the same thing on My Crypto and see if you can find the same places to do it. Etherscan is one block explorer. There's several others. ETHplorer is another block explorer that you could try to do a similar thing. And if you're really ambitious, I already told you how you can make money off of, or you can make watches off of just being a repossession person. But if you made it to the end here, I do have some extra credit for you. One other contract there, you may want to write down the refunds.unicornsrus.eth. There is a challenge there. I'll pull that one up here. This one is a smart contract. It is created by me again. The code for this one I did actually post. The key for this one that you may want to pay attention to is there's a function here called claim reward. I will tell you the logic of that one. If you can get that function to execute, then it unlocks for you the ability to sell back your watch to me at the same price that you got them to. So I'm willing to give you back your Ether for your watch if you can solve my puzzle and trigger that function. So there's your incentive. All right. Any other questions on what we covered?
That was refunds.unicornrus.eth?
Yes. I'll pull that one back up here. Refunds, yep.
Are these slides going to be available?
Yes, and I'll post the slides when we post the video as well. All right. I'll be available for questions after. Otherwise, thank you very much for coming and hope to see you at another Madison Blockchain event.